Identifying common minerals. Let's begin with minerals that have a non-metallic luster. Now, if you don't know anything about the physical properties of minerals, such as luster, you can watch the Physical Property Minerals podcast 1 and 2. In this podcast, I'm simply going to point out the most diagnostic physical properties of many common minerals and some of their economic uses. Beginning with quartz. If quartz gets to grow unimpeded, it develops this beautiful hexagonal crystal. But frankly, most quartz doesn't get so lucky. It looks like this, shapeless, but very, very glassy. Also, it's hard. It scratches glass. It's got a hardness of 7. But let's just divide hardness into 3 categories. Hard, which means it scratches glass. Soft, it doesn't scratch glass. And very soft, which means you can scratch it with your fingernail. Quartz is hard. It has no cleavage planes, but it does break with conchoidal fracture. Its formula is SiO2. It's really the mother of all silicates. And it's used to make glass. What color is it? Well, beware. Color is confusing. All of these are forms of quartz. If a mineral is capable of being clear, it's also capable of having just about any color it wants, thanks to small impurities. So color is a terrible way to try to identify light-colored minerals. K-Feldspar is an important rock-forming mineral. It's got 2 cleavage planes which are at right angles. Also, it scratches glass, but not terribly well. It's got these funny, wavy lines called lamellae. It could be pink or it could be white, and yes, it is a silicate. Plagioclase Feldspar also has 2 cleavage planes, but they're not quite at right angles. Unlike those wavy lamellae, it has incredibly straight, parallel scratches or striations. It could be white if it has a lot of sodium in it, like this sample of Augite, or it could be gray if it has a lot of calcium and lots of colors in between. Its formula shows that it can have either sodium, calcium, or a combination thereof. Muscovite mica is very easy to recognize because it has a perfect single cleavage plane. We call that basal cleavage. It can be so thin that, as you can see, could even be translucent or transparent. It's an aluminum silicate. It's soft, but not quite soft enough to scratch with your fingernail. It could be found as windows. It could be even found in the glitter in makeup. Biotite mica is just like Muscovite, except it's black. Its black color comes from the presence of iron or magnesium in it. Hornblende, which is one of the amphibole minerals, is a silicate. It's black and it's splintery. It barely scratches glass, so that's not a great diagnostic property. What is diagnostic is that it has 2 cleavage planes that are at 56 or 124 degrees. So what's important to remember is that the cleavage planes are not at right angles. It's a double-chain silicate. But please don't confuse it with augite, a pyroxine silicate. It's also green or black, but it's very, very blocky. It has 2 cleavage planes, but those cleavage planes are at right angles. So which is which? I hope you recognize that the one on the left is the augite and the one on the right is the hornblende. Both of them have a light to pale gray streak, so that's no way to tell them apart. Tell them by their cleavage planes. Olivine, another silicate, is rarely found as a single crystal, but as a mass of crystals. That gives it kind of a sugary appearance, and the crystals tend to be olive green in color. It scratches glass. If you had a beautiful crystal of it, you would call it peridot, which is the birthstone for August. And olivine is the major component of Pyrite, the rock of the Earth's mantle. Talc is a sheet silicate, but you can't see the sheets because they're much too small to see individual crystals. If you scratch it with your fingernail, you'll find that you get talcum powder. Talc may have a pearly luster, and it feels soapy. That will help you distinguish it from Kaolinite. Kaolinite is another sheet silicate, but once again, with the sheets too small to see. It's very soft. You can scratch it with your fingernail, but unlike the talc, it has a dull luster and it feels powdery or chalky. Which is which? Oh yeah, Kaolinite and talc. Halite is NaCl, otherwise known as table salt, and is easy to identify because of its perfect cubic cleavage. 3 cleavage planes, all at right angles. It does not scratch glass, and of course it has a salty taste. But it's a really, really bad idea to use its taste to distinguish it from similar glassy minerals. After all, salt is pretty good at killing bacteria. But if you were to taste it and find that instead you had gone and tasted calcite, then you've got to worry. Who else has licked that sample? Ick. So if you want to tell halite from something like calcite or fluorite, go ahead and look carefully at its cleavage planes. As I said, the halite has perfect cubic cleavage, whereas calcite does not. Calcite's 3 cleavage planes are not at right angles, so it has a rhombohedral cleavage. It doesn't scratch glass, and another diagnostic feature is that calcite will react vigorously to acid. Calcite's the main mineral used in cement. Another feature it has, you can see if you're lucky enough to get a nice clear crystal of calcite, known as an Iceland spar. If you look through it, you'll notice that you can see double. That's double refraction. That will help to distinguish it from the halite above and from another glassy mineral called gypsum. Gypsum has 2 really good cleavage planes, but it does have a weak third plane, so it's possible for gypsum to look like a rhombus. However, it's very easy to distinguish gypsum from calcite because gypsum scratches with your fingernail. Gypsum is used to make plaster. In fact, if you look at the formula, you notice that it has water in it. If you want to make plaster of Paris, simply heat up the gypsum and it will remove the water. Add the water, you have plaster. Fluorite is another glassy mineral, but it differs because it has 4 cleavage planes, giving you this beautiful double pyramid. However, many samples you see may not be so pretty. So you have to know some other features. One is that it has a lot of cleavage planes, and they're not at right angles, and they just don't look at angles that could possibly be calcite. But it doesn't scratch glass, and it has many colors. It is used to make hydrofluoric acid. Kernite may not be many people's idea of a common mineral, but I like to use it because our class gets to go visit a borax mine. Kernite is a borate mineral used to make borax. It might look a bit like a quartz crystal, but it has a particularly low specific gravity. Also, it's soft and the crystals are very brittle. Sulfur, the element S, is very easy to recognize because it's yellow, with a yellow streak. It's composed of clusters of very brittle crystals. And if you're still not certain whether you have sulfur, go ahead and take a whiff. It smells like sulfur, which is, of course, rotten eggs. Sulfur is used to make sulfuric acid. Here are 2 more minerals that are easy to tell by their color, azurite and malachite. They are both copper carbonates, and both of them can be used as an ore of copper. The azurite, as you might guess from its name, is azure blue, and the malachite is green. They're both soft, so there's really no excuse for confusing the grass green malachite for the hard olive green olivine. Now let's take a look at minerals that have a metallic luster, starting with hematite. Hematite can be confusing because it has many forms. Some forms are soft, like this red ochre on the left, and non-metallic, while others are hard and metallic. So how can you tell whether you have hematite? Simple. Look for the red streak. Hematite is an iron oxide, Fe2O3. It's an ore of iron. Because its streak is red, it can be powdered to make paint or red makeup. What is this nondescript rock? It could be metallic, might not look terribly metallic. How do you know what it is? Simple. Add a magnet. For this is magnetite. Some magnetite is so magnetic that it is a magnet, while others simply attract a magnet. It has a particularly high specific gravity, which will also help you to distinguish it from the hematite. If you don't have a magnet handy, just take a look. It has a gray streak, unlike hematite's red streak. Like hematite, it's an iron oxide, But with Fe3O4, it's an even more important ore of iron. There's no doubt about the metallic luster of this metal, which has beautiful cubic crystals. You probably all recognize pyrite, known as fool's gold. But unlike gold, pyrite has a gray streak. It's also not as heavy as gold. It is heavy, and it's brittle. Unlike gold, which is malleable. Pyrite is an iron sulfide, FeS2. For some reason, many of my students have confused pyrite with this mineral, which is perhaps understandable if a student were colorblind, because pyrite's gold and galena is silver. Galena does have perfect cubic cleavage, which could be confused with pyrite's crystals, I suppose, and its very, very high specific gravity makes it quite distinctive. Galena is the ore of lead. Graphite is considered submetallic, for it could look metallic or it could look dull. It's very easily scratched with a fingernail. And more importantly, you can write with it. It is the, quote, lead in pencil lead. It has a slippery feel to it and a particularly low specific gravity. One reason for that is that it's not composed of metals like the other metallic minerals. It's composed of sheets of carbon. And that, everyone, is the end.